My name is Baptiste Tignegre. I'm a plant breeder by training, and currently I am the Cowpea project manager based in ATF Abuja. I'm also the representative of ATF for West Africa. Let's say that, as you know, cowpea is a legume crop grown in West Africa, and as you know, cowpea is one of the top crop produced in Nigeria. Nigeria produce huge quantity of cowpea, but at the same time, Nigeria is one of the highest consumer of cowpea in the region. Now, you need to know that cowpea production is facing a certain number of production constraints, and among the constraints, one of the most important constraints are insects. Insects damage cowpea from planting to storage, and in the context of Nigeria, one of the insects called the PBR cowpea is damaging on cowpea and can cause complete yield loss at farmers level. So breeders have been working for a long time to find a solution to control these pod borer that are affecting cowpea production, but conventional methods revealed to be weak in the providing such results that could help control this insect. So ATF worked together with partners including IAR in Nigeria, CSIRO in Ghana, INERA in Burkina Faso, and a new product that is genetically engineered, which means it's a biotech product, was developed that confer the resistance to this pod borer. In short, that's how we come to develop PBR cowpea. So PBR cowpea, in short, confer the resistance to the pod borer that is damaging in cowpea production, and require sometime 6 to 8 spray before farmers can harvest. This is the grain of the pod borer resistant cowpea developed by IAR, ATF, and partners. As you can see, this cowpea doesn't differ from other cowpea local varieties, except that it just confers the resistance to this pod borer that is damaging to cowpea in the field. That's the attribute of this PBR cowpea. So the plants, leaves and grain are similar to the local and improved variety already disseminated in Nigeria and other African countries. So as I said, this cowpea was developed by using the technology of genetic engineering, which means that because it was not possible to use the conventional methods, what are conventional methods used by breeders? They generally make crosses, they develop generation, they screen the generation to identify, to select progenies with resistance, and they continue developing and multiplying the seed. But with PBR cowpea, it was not possible to use these conventional methods. So genetic engineering was exploited to develop this technology. How this happened? Biotechnologists use the technology of gene, the transformation of DNA, and it was possible to insert this gene into cowpea so that this gene express in the providing the resistance to the pod borer in cowpea. That's how it worked. So it's not a conventional method, but a method provided by biotechnology and through the genetic engineering. As you might know, if you consider year 2021, northern Nigeria suffer drought in the field, so that farmers lost their production. In 2022, we had another extreme weather advert that were flood, and cowpea fields were affected by floods in northern Nigeria. So because of climate unpredictability, it's difficult to have sustained increased cowpea production for our farmers in the northern Nigeria, but also in dry area of other countries in West Africa. So to mitigate this climate adverse like drought, heat, and floods, we have decided to go for dry season production under irrigation. As you might know, production of cowpea is possible during dry season. It just requires that you have irrigation facilities. It also requires that farmers we fill the gap in terms of knowledge required by farmers to produce cowpea during dry season. And during the dry season, the pressure of insects and other diseases are reduced, and cowpea potential production is higher than during the rainy season. That's why we decided to go for dry season production to be able to fill the gap in the production of cowpea. So we are targeting dry season production to increase production of cowpea, but our strategy is to go and evolve toward a year-round production of cowpea, exploiting the two seasons. And this will be applied to grain production for consumption, but also to seed production by seed enterprises and seed partners as well. Insect pressure and diseases can fluctuate. It depends on the season. Insect pressure diseases tend to be more important during the rainy season because of humidity. Humidity is favorable, create favorable environment for insect and diseases to multiply, to increase. But during dry season, because it's hot, it's dry, it's not that so favorable to insect and disease. That's why generally you will see that during dry season under irrigation, the potential yield of cowpea will increase, and sometimes you can go beyond 2 tons per hectare because water is available at any time, the photosynthesis is maximum, and also insect pressure are low than as compared to the rainy season. That's why targeting this period mostly for seed production is very important to improve cowpea production in general.